Hi students, welcome you all to Toppers e-learning classes. Understand every single concept and be a topper. Today we are discussing 10th Cbse Mathematics chapter number 1, Real Numbers. Exercise 1.3, question number 3. In question number 3 there are 3 sub-questions are there, each one we can do. First question, prove that 1 by root 2 is irrational. 1 by root 2 is irrational. So those who didn't watch the theory classes, just watch that one. Just in details we have explained how we can prove root 2, root 3, root 5, root 7, etc. is irrational using contradiction method of proof. Okay. After that we are doing the chapter exercise. This is the 1.3 third question, sub question 1. First, we have to assume that the given irrational number is a rational number. So, first step, let us assume that 1 by root 2 is a rational number. Actually, it is irrational, but we are assuming it is a rational number. So, it is a contrary assumption. It is a contrary assumption. Now, step 2. Since we have assumed that 1 by root 2 is a rational number, we can write it in the standard form. 1 by root 2 is equal to p by q, where p and q are integers and q not equal to 0. That is standard form of rational number, right? Also, we have to assume that p and q are in the simplest form. So we can call them as co-prime. They have common factors, only one. Fine. So, third step. Now we are going to write by rearranging, we can reciprocate 1 by root 2. So root 2 by 1 is root 2. P by q on reciprocating will become q by p. So we got it root 2 equal to q by p by rearranging the second statement. Now we can say that p by q, I mean q by p, this is mistake is there, it is not p by q, it is q by p. Okay, q by p is a rational number since p and q are integers. Numerator, denominators are integers, right? They are integers. So this RHS, q by p is a rational number. So left side, root 2 should also be a rational number because it's an equation, correct? Okay, so next step we can say that root 2 is irrational. Why the reason? From statement 3 and statement 4. In 3 we are saying root 2 equal to q by p, and in statement 4 we are saying q by p, the RHS right hand side is a rational number. So according to that, the LHS left hand side also should be a rational number. So we are arguing, we are make a statement that root 2 is a rational number. Root 2 is rational number. Fine, next step. This contradicts the fact that root 2 is irrational. We have already proved that root 2 is irrational in the previous classes. Okay, now according to the fifth statement, we got root 2 is a rational number. So this contradicts the fact that root 2 is irrational. What is the reason? This contradiction has arisen. This contradiction has arisen because of our incorrect assumption. Incorrect assumption. Therefore, 1 by root 2 is irrational number. Irrational number. By 7 steps, we have proved that 1 by root 2 is irrational number. Correct? Hence we have proved. Hence we have proved. Okay. So let us go for the next question. This is the second question. Prove that 7 root 5 is irrational. 7 root 5, we have to prove that it is irrational. Same contradiction method of proof we will use to prove this. So first we have to assume that 7 root 5 is a rational number. So let us assume that 7 root 5 is a rational number. This is a contrary assumption. Now we have to write it in the p by q form. So 7 by root 5 equal to p by q, where p and q are integers and q not equal to 0. We have written their standard form. And also we are assuming that p and q are coprimes by making p and q to their lowest term by simplification. Now we'll make root 5 as the subject. So for that, we can bring the 7 to the right side. So root 5 equal to p by q, p by 7q. This 7 to the left side, we brought to the right side, so it will is divided by 7. So root 5 equal to p by 7q. We made root 5 as the subject by rearranging it. Next step, we can say that the RHS is a rational number. What is the reason? P by 7q, this RHS part, p by q is a rational number. The reason is what? 7 is a rational number, right? P is a rational number. So I mean integer. 7 is an integer. P is an integer. Q is an integer. So an integer divided by another integer where the denominator is not equal to 0 is the general form of rational number. So we can say that p by 7q is rational number. We said the RHS is rational. So we can say the LHS root 5 also rational. So that is our next step. Therefore, root 7 is a rational number from 3 and 4. 3 and 4, we can say that root 7 is a rational number. But it is a wrong statement actually. We know root 7 is irrational. We have proved before. Therefore, we can say this contradicts the fact that root 7 is irrational. This contradiction has arisen because of our incorrect assumption. Therefore, 7 root 5 is irrational. 7 root 5 is irrational. So we proved that 7 root 5 is irrational number. Okay, fine. Okay, so we'll go for the next. Okay, so let us work out the third question. What is the third question? Prove that 6 plus root 2 is irrational. 6 plus root 2 is irrational. So same method, we can use same method. Okay. First, we have to assume that 6 plus root 2 is a rational number. First step, let us assume that 6 plus root 2 is a rational number. Contrary assumption, incorrect assumption. Now, what is the next step? We have to write that 6 plus root 2 in the standard form, p by q form. That is the next step. So in second step, we are writing 6 plus root 2 equal to p by q, where p and q are integers and q not equal to 0. And also let p and q are coprimes. This p and q we are taking to the simplest form, okay, the lowest term. If any common factors, we have to cancel it and we have to bring it smallest form. So they have only one as the common factor. So we can say that p by q are coprimes. Now we have to make root 2 as the subject. So for that, we have to bring 6 to the RHS. When you are bringing this plus 6 to the right, it will become minus 6. So we'll get root 2 equal to p by q minus 6. Next step, we have to argue this RHS is a rational number. Okay. So we are saying p by q minus 6 is a rational number. What is the reason? Since 6, p and q are integers. You know 6 is an integer and p and q are integers already we have considered in the second statement. So p by q minus 6 is a rational number, right? An integer divided by an integer. This is a rational number. This is also a rational number, right? Fine. So a rational number minus rational number is also rational number. Rational number is rational number is closed under subtraction. Fine. Next step, since this RHS p by q minus 6 is a rational number, we can state that root 2 is also a rational number. That is the next step. Therefore, root 2 is rational from statement 3 and 4. Statement 3 is saying root 2 equal to p by q minus 6. Statement 4 say p by q minus 6 is a rational number. If RHS is a rational number, undoubtedly LHS also will be a rational number. So that's why we are stating that root 2 is a rational number, but it is a contradiction. We know root 2 is irrational. Next statement, we have to say that this contradicts the fact that root 2 is irrational. What is the reason? This contradiction has arisen because of our incorrect assumption. So in next statement, we have to conclude that therefore 6 plus root 2 is irrational. 6 plus root 2 is irrational. So we have proved that root 6 plus root 2 is irrational. So it is very easy. Only the thing you have to do this step by step. Just remember how we are arguing, what is the reason for each statement, each argument, and step by 7 steps we can conclude that the given irrational number, we are proving that given number is a irrational. Okay, so this is a sure question for Cbse board exam, so practice it well, and any doubts you can email me or registered students can ask me in the online classes. Okay, fine, see you in the next class. Bye bye.